So, next topic, initially we saw about in the last class we discussed about the basic fundamental issues of a distributed system and different computing models of a distributed system, and we have seen also the basic characteristics of a distributed system. Then next focus is that how the inter-process communication takes place in a distributed system. As you know that whenever you run any application on a distributed system, basically they are converted to set of processes, right? Or you can say one application can be divided into a number of processes or tasks, right? And this set of processes for a particular application must be executed on a distributed system, right? And a distributed system, if you see the underlying layer, on the bottom layer you have the computers or machines, a set of machines, or we call it as a network. When a set of machines are combined together and allow the communication among themselves, we call it as a network, right. So, on the top of network we have the distributed system, or you can say computer network is an integral part of the distributed system. Without computer network, it is not possible to establish a distributed system. Again, there are large number of computer networks depending upon their characteristics, including internet. Internet is the best example of computer network, which works under the protocol TCP/IP, which is a 5-layer protocol. And we have seen also the OSI reference model, where we have seen 7 layers, starting from physical layer till the application layer, and every layer has its own function. So, depending upon the network, different protocols have been introduced, and based upon the protocols, the communication is possible between two computers or two machines. But as the characteristics of a distributed system shows that many underlying details should be concealed from the applications or user, or some kind of transparency should be maintained to achieve single coherent view property and single system image, SSI property, or we call single coherent view, as if the users will feel we are working on a single PC. Though a loosely coupled architecture or loosely coupled computer network is present in the bottom layer. So, to view from the top side of a distributed system, you will come across a set of processes, isn't it? Set of processes, and these processes can be user process or can be kernel process. Kernel process. If it is a kernel process, it is a part of the operating system, and if it is a user process, it is a part of the application. And the user wants to use both the processes, user processes as well as the kernel processes, to access any kind of hardware or software resources, right. And a distributed system, several resources are there, including hardware and software. Example, name resources, file resources, register resources, and database services. All these are the resources which needs to be managed, and the resource monitoring process, whether it is a part of kernel or user, it is itself, the management itself is a process, right. Suppose you want to access a file, so to access that file there is a process, to manage this file also there is a process. So, everything has to be reduced to set of processes, and when you execute this set of processes on a distributed system, and if the communication is allowed between every pair of processes, then we call the distributed system as compared to a computer network, right. I think understood the difference between a distributed system and a computer network. So, without computer network, distributed system is not possible, right, or it is the backbone of the distributed system. Now, whenever several processes suppose are created for a particular application, there must be a communication among these processes. Without the communication between two processes, I think we cannot accomplish our task, we cannot accomplish our applications. Then how to establish the communication between any pair of processes in a distributed system is the main topic. It is the second topic of our syllabus, that is inter-process communication. Inter means in between, process means process. So, in between two processes, how the communication take place. So, the communication can be intra process or can be inter process. Intra means within the process, that we are not talking about. We are talking about the communication between two processes, and both the processes may coexist on a single computer, or they can be in two different computers, or in the worst case they can be in two different computers which are much away from each other. There are three instances we can observe. One is that very simple fact that both the process coexist on a single computer or single machine, that is one. Second, both the processes are executing in two different computers, right. And third is they are executing in two different computers, but both the computers are too far away, maybe thousands, lakhs kilometers away from each other, but one process wants to communicate with another process. So, what are the difficulties we are facing while the communication takes place? So, the simplest case is that if both the processes are executed on the same computer, the operating system which is running on that system, on that computer, can handle it, right. But whenever two processes are executed on two different computers within a LAN, suppose local area network, we know that networks can be divided into three types: local area network, metropolitan area network, and third is the wide area network. So, if both the computers are present in a single LAN, then how the communication takes place, right. So, one fact here we observe that irrespective of the destination, because one will be the sender and another is the receiver, and the communication can be two type: client server or peer to peer, that we have seen. What is client server communication? Client will send a message to server, and a server will invoke some procedure to carry out some task depending on the type of message, right. And after execution of that server process, then some results will be returned to the client or sender. That is what the client server technology says. Based upon this paradigm, the communication takes place. So, here the goal for inter-process communication in a distributed system to provide a set of abstractions, or you can say which can be converted to libraries by some languages. Set of abstractions need to be used. One abstraction is that we can define some ports. A process can create or can use several ports to transmit the data. Suppose a process has 3 ports, then 3 data can be simultaneously transferred to the server, right. So, initially I told you that there is a computer. On that computer we execute process, then on that process we should have the software ports. I am not telling about the physical ports, because the distributed system everything is abstraction, right. So, processes will have a number of ports to communicate or to transmit the data. Then after transmission, the data should be propagated, communicated using the communication channel. For that we need a communication identifier, right, and everything is virtual, logical. So, a process will be created on a computer, and that process will use some ports to transfer the data, and while transferring the data, it has to use a communication identifier to transmit the data through the channel, communication channel, or you call channel identifier or communication identifier. And this destination process should be location independent. Sender will just send the data. It will not be bothered about what kind of operating system is used in the destination machine, what is the architecture, and what is the platform used in the destination system. So, to send the message to a location independent destination. Am I clear? That means as if the sender will feel the receiver process is very nearby. So, this transparency will be possible only when we add several abstractions like ports and communication identifiers, right. So, ports, by using software ports and communication identifier, it is possible to achieve the transparency between the communication between sender as well as the receiver. Am I clear? Okay. Then how to achieve this transparency? How to achieve that a successful communication or effective communication between sender and the receiver. And what are the major problems we should focus so that the interprocess communication is effective, not only effective, it should be effective and efficient. What is efficient? How fast the message can be received by the receiver, that is efficiency. What is effective? Whatever the data is sent, that should be arrived at the destination, integrity of the message. Am I clear? So, this effective and efficient interprocess communication is possible if we are able to design the communication protocols, or we call interprocess communication protocol. So, what should be the characteristics of our interprocess protocols? So, okay. So, these are the things you have to focus while designing a protocol for interprocess communication. So, whether the communication is client server or group communication, because again we can divide the communication in two types: interprocess communication, client server communication or group communication. What is client server communication? Client sends a request to server, a single message, and server give a reply to client after executing some procedure. After invoking and execution of a procedure at the server side, it will give a reply or result. So, that is possible using unicast communication. Uni means one, only by exchanging one message the communication can be possible. That is one solution. Second is group communication, that multicast. A sender can send several messages to the different servers. Suppose 100 servers are there, it can send 100 messages to 100 different servers, that is called multicast, and it is different from the broadcast. Broadcast means all the nodes, but multicast means a group of nodes which are intended, which are the real recipients of the message, they are going to receive, right. So, to allow the group communication, we have to define a group, right, and initially you create a group, then send a message to that group. So, all the members in that group are going to receive this message by using the multicast communication. And in the worst case, a collection of unicast communication can be done as a multicast communication. You can have a single primitive for transmission of the message to all the group members, or you can give the message to each and every destination by using several unicast messages. So, this is one way, this is another way. That means, a multicast communication is achievable by using the set of unicast communications. Okay. So, therefore, we should have suitable communication primitives or libraries for communication. Suppose you have a primitive for multicast communication, just only once you use that syntax and directly you can transfer the data. Then while designing the protocol, you should check that redundancy should be avoided, both in the original message which you are sending and the acknowledgements which are being received by the client. When you send a message, it may so happen that same message may be transmitted several times. So, there the efficiency comes. For example, if you are sending a message ABC and if you are transferring ABC a number of times, so unnecessarily your communication overhead will be high and computation overhead will be high. So, whenever you design a protocol, two things are important. One is that computational overhead should be less and communication overhead should be less. You have to focus on computation and communication overhead. So, I think clear, avoid redundancy for original message as well as the acknowledgements. Then third thing you have to see that minimum number of message exchanges, as minimum as possible. To accomplish a task, you have to exchange only minimum number of messages. Then next is structure or format of the message, right. What is the structure and format of the message? So, if this is the message and message has number of fields, it may have computer ID, host ID, or it can have process ID, or it can have the some elements for security, some elements for protection, and finally the actual data which we call the payload. So, this is a typical message format to be transmitted from source to destination. So, can I say that these four things whatever we discussed, these constitute the syntax of the protocol. Am I clear? So, the syntax, in the syntax of the protocol you have to check what should be the format of the message and how to avoid the redundancy. All these issues are coming under the syntax of the protocol for inter-process communication. The next important thing is the semantics of the message transmission. What do you mean by the semantics? These are the syntax, but what is the semantics of the message transmission? So, this is known as the semantics of the message transmission. What is semantics? This is the sender, this is the receiver, sender and receiver. Sender is sending a message, let us take a request message, and the receiver is sending a reply message. What kind of message format, that we shall see, because that is coming under the syntax. But what is the semantics? When the sender sends a request, the request message was never received by the server. So, what will happen? When sender sends a request message to the receiver, the request message could not be received by the server. So, what is the solution? Again you have to send, but how often you will send, at what time you will send, and what is the interval between two sends, two successive sends. So, these are the issues we are going to discuss in detail, right. So, but these are the preliminary, these are the preliminary cases which are coming under the semantics, and different protocols will follow different rules. I will give the examples. Then second question comes, the server failed during its task or still working on it. Assume that the request message could be received by the receiver, and the server in the destination could invoke the corresponding procedure to carry out a task. That is also correct, that is also proper, right. And after invoking, the procedure could not be completed, that is server failed. Server is a process which failed to execute the task, or it is still working on it, not ending, not completing. That may be a case. First case is very clear, the request message could not be received by the receiver, server. Second is that request message could be received and the procedure could be invoked. The procedure could be started its execution but not completed, either due to failure or due to some reason it is still working on it. That is the second case. Am I clear? Now, we have to think of the solutions for this. Each of these, what are the solutions by different protocols, right? Okay, one very interesting question comes, that when the request message was sent but the receiver could not receive, right? How do send the second time the same message? The message is lost. After sending that message to the server, the message is lost. So, you have to use some kind of buffer to keep that message temporarily, and when the message was sent, if it could not be received by the receiver, you can resend it from the buffer, and when you get an acknowledgement, you empty the buffer. So, these are the possible solutions comes to mind whenever we discuss this type of problems. Then third one is, the server received the request, performed the operation, but the reply could not be sent. So, request message was successfully transmitted and received by the receiver, and server could execute the corresponding procedure for that task, and while sending the reply message or acknowledgement message to the sender, on the way the reply message was lost. So, how to handle these three cases? So, if you could handle for a single message transmission, and if it is repeatedly followed for all successive messages, then your protocol will be effective or efficient. So, we are bothered about the how to send a message from sender to receiver by considering these three issues, and these are called the semantics of the message transmission for an inter-process communication. I think understood the difference between syntax and the semantics of the message transmission in a inter-process communication, right. Now, we shall see how to tackle these problems, but these problems will be tackled for the common interprocess communication when the processes are in a LAN, in a small geographical area, and when two computers are far away from each other. So, this interprocess communication mechanism may not work. For that, we have to go for RPC. RP stands for remote procedure calling. We have to call a procedure remotely, very far away from the sender, and we shall see what are the different constraints. So, RPC is a form of IPC. Remote procedure calling is a form of interprocess communication which allows the communication between two processes who are far away from each other, and both the processes are executed in different platform, different language support and different architecture. So, due to this heterogeneity of the platform architecture and the networking, we use RPC as a form of IPC for successful communication, right. So, now let us go to what are the basic building blocks required to allow this communication to be effective and efficient. So, basic building blocks for the message transmission for interprocess communication. So, one common issue comes that we use various type of data structures in the program. When you write a program, I think no program is possible without using a data structure. At least we are using an array, a structure, tree or stack, queue. There are several data structures which are being used in your program, right. And these data structures which stores the data, so that stores in a logical way, a logical form. But physically, whenever this data will be transmitted by a communication channel, it is sequential. Am I correct? So, when you use a process, we use a data structure which is very much logical in nature, but when you transmit that same data in binary form, it is sequential in nature. So, these data structures must be mapped to XDR. XDR stands for external data representation, and this sequential representation should be such that it should be understood by destination of different types. For example, I wrote a program in C, I use a data structure and I am sending a message, I am communicating with a process which is using the language Java. Now, this message is going to be received by the server which is executing a Java program, clear, and the data structure which you have defined in C is not same as Java, syntactically and sometimes semantically also. Am I correct? And whenever this C data structure is converted to a sequential form, the data is transmitted sequentially, and when it is received, it must be received by the Java program or Java process, server process. What exactly I want to see, that this sender process is working on a different language, different platform, different machine, but here also in the destination it uses a different language, different machine and different operating system or platform. Both the process wants to communicate. So, for that we need an external data representation such that both the machines should commonly agree on that particular format. Am I clear? And this XDR has been standardized by many standardizing organizations, like we have SUN RPC, SUN RPC. So, this is a very much worldwide standard for external data representation, so that many heterogeneous platforms, many computers with different features can agree on this representation. That is called the data representation or external data representation. So, what is the common issues comes, that we need an agreed XDR to allow the communication. External data representation should be there, and if the communication is connection oriented, okay, so this external data representation can be omitted if both the machines are similar type, and if they are different types, then we need a XDR. And if the communication is connection oriented, then sender can negotiate with the receiver that I am sending this, are you agree to accept this? And if the receiver is able to accept by using some kind of tools or technique something, then external data representation can be also avoided. But if both the machines and both the processes are executing on a heterogeneous platform, I think the XDR has become important and is become essential for the communication. Let us take a typical example of the XDR. So, let us take, I want to send this message from source to destination and the message format is given. It is a, though it is not a standard format, but we can consider as an example that at a time you can write only 4 bytes and you know that whether you are following ASCII or ABCDIC, we need 8 bits at most. So, 1 byte to represent a character, right. So, 4 bytes means 4 characters we can very well represent, and this fast the format says that the fast content shows the length of sequence. So, here ROUR, so length is what 4 and KELA 4. So, 4 plus 4 8, am I clear? Then here length of sequence is 10, Sundargarh, sorry, so it is 11, 4 plus 4, 8 plus 3, 11 and 1 is blank. But format says that you should have a format such that the number of blank spaces should be less, because this the blank space is also a character which will also send along with the message, that should be avoided. So, this is the message format and 2020 an integer data, or we call cardinal. Cardinal means integer, right. So, what is the data you want to send or message you want to send? Raurkela Sundargarh 2020. This is the message I want to transmit, and for that this is the representation of the data, and this data will be available initially in a data structure available at the sender process. So, okay, and whenever they are transmitted, the receiver, sorry, initially this will be maintained in your data structure, then it will be converted to XDR, and XDR is used for communication sequentially from the sender to receiver. Then receiver will again receive on its own form, and sometimes what happens, suppose the receiver is very much heterogeneous with respect to the sender, then you may have to use an architecture identifier, and this is one of the external data representation. Now, we shall see how that a normal IPC is different from the RPC. So, as I told you, RPC is a form of IPC. So, IPC is a set of primitives for the exchange of data among multiple threads. So, you can consider threads is also a process, right, in one or more processes, or threads can be considered as a port in the process. A process can be divided into number of threads, or it can consist of number of threads for communication. Then RPC is a form of IPC technology that allows a computer program to cause a structure or to cause a subroutine or procedure to execute in another address space. What is address space? Suppose you are executing a process and this process can be executed in the address space of another network or another machine, right. So, calling methods remotely at a system. Remotely means it can be too far away from the sender, right. So, caller whenever calls, it has to invoke a call trap, just one kind of interrupt. Caller will generate a call trap, and this call trap will invoke the corresponding kernel process on the operating system. Then from the kernel process, one return trap will be executed to send the reply from the server to the caller, right. So, now this is the client, caller means the client and S means server. So, when the client runs its process, it has to run its own address space and it has to prepare a message in its own address space, and that message will be copied to the kernel's address space, and from the kernel's address space it will go to the server's address space where the corresponding procedure will be executed, and once the execution is over, it will return a result, and that result will be sent back to the caller or to the client, right. And whenever these copies are produced, so at least 2 copies of the same message are produced in 2 different address space to allow the communication in case of RPC, and our goal is to reduce the number of copies, number of messages, and all these things happens at the runtime. Unlike if you are calling a procedure in your program, a normal call that occurs at the compile time. Normal, suppose you are calling the both client and server, both are present in the single machine. So, things are done at the compile time, but here it is done at the run time in case of RPC. So, what are the features required? Here you have to execute two traps, one is call trap, another is return trap, and you have to have two contexts. One is client address space context, another is server address space context, and this context must be switched from client to server address space, what we call the context switching. So, the context switching overhead is high in case of RPC. So, here one major problem comes context switching. Are you understand the context? The concerned address space, and here you need to validation and arguments and multiple copies. These issues must be handled. One is that you are executing in two traps. Second is two contests are created, both are the client and the server side, and context switching is necessary. That will create an overhead that should be avoided, and it should be validated. Validated means whatever the data you sent to the destination, it should be correct. So, whenever a client procedure or client process calls a server procedure, some arguments need to be exchanged, parameters need to be exchanged, and those arguments must be kept track, because ultimately whenever you transfer the data or message to a destination process, you have to transfer via arguments, via parameters, and multiple copies. As I told you, you need to have at least two copies for successful data transfer. So, all these issues must be tackled for a RPC system. Example of RPC system, gRPC. So, gRPC stands for Google RPC. So, Google has recently developed a RPC system, and there are a lot of potential or capability of this gRPC. So, this gRPC is a free So, this example RPC system gRPC, that is Google RPC, it is a free and open source framework developed by Google. You can download and install and check how the communication takes place between two processes, and it is a part of the Cloud Native Computation Foundation. So, it can work on the cloud also, Google Cloud, right. Then it handles request and response, whatever you call request and reply. So, these are the exact syntax used in the gRPC, request and a response. You can send a request and it will allow to respond. So, for that what you have to do? You have to run a client side code with proper syntax, which is defined by gRPC, and in the server side you have to run a server code. In the client side you have to run a client code, in the server side you have to run a server code. And by using these two codes, by proper synchronization, we will be able to communicate between the client and the server. Okay, we are not going to the exact syntax. If it is possible, we will do it in the laboratory about the exact syntax, but this is a mechanism you can say. Using the proper syntax and semantics, it is possible to establish the inter-process communication between two remote processes. Another interesting thing is that it is fast and efficient. That is a very important point. Second is low latency. As soon as you put a request, you can get immediate reply, response. Then it supports streaming. Suppose a video data is there, you can also transmit it. Then it is language independent. Client can run in any language, C, Pascal, Java, COBOL, whatever it may be, and the server can be maybe using different languages. So, language independent, that is an interesting point. And next is super easy to plug in authentication. That means, if you need an authentication service or protection service, you can invoke another procedure, and a plugin, just like the way you plug in to get the power, in the same way you can invoke this procedure for getting this authentication service. Then load balancing, it allows logging, you can remote login, you can log in another machine which is far away from the client machine, and finally it allows monitoring. So, these are the important features of the gRPCs, and how these are achieved is known as mechanism. In fact, we have to see what is what and what is how. So, this is what we discussed about what is RPC. and the only thing is remaining that how this RPC is implemented, that we call mechanism. So, how tells your mechanism and what tells about the policies. So, policies and mechanisms for every protocol needs to be studied for RPC, any kind of RPC or IPC. So, this is what we discussed about the what or policies, but next class we shall see what are the different mechanisms to support RPC and IPC.